Press the bell icon on the YouTube app and never miss another update.
Welcome back, children. Today we are starting the discussion of multiple choice questions for ionic equilibrium. So we have finished chemical equilibrium questions. Now we are going to discuss the concepts with respect to ionic equilibrium. Correct? So we'll start a discussion on ionic equilibrium. Right? Good. So let us see some questions with respect to ionic equilibrium here. Our question number 1, I have taken ionic equilibrium now, so here I'll start question series from question number 1. Our question with respect to ionic equilibriums are, first one, calculate the percentage ionization of 0.01 molar acetic acid in 0.1 molar HCl. Ka of acetic acid is 1.8 into 10 to the power minus 5. Question given is, we have to find out the percentage ionization. That means we have to find out the alpha value. So percentage alpha we have to find out. When Ka is given, how much is Ka? 1.8 into 10 to the power minus 5. Ka value is given. And for what we have to find it out? We have to find it out for acetic acid whose concentration is 0.01 molar in 0.1 molar HCl. So we have to find out percentage degree of dissociation. K is given of acetic acid whose concentration is 0.01 molar in 0.1 molar HCl. Options are 0.18%. Second option is 0.018%. Third option is 1.8%. And fourth option is 18%. So I repeat the question. Calculate the percentage ionization of 0.01 molar acetic acid in 0.1 molar HCl. Ka of acetic acid is 1.8 into 10 to the power minus 5, which is given to us. Let us see. Acetic acid will dissociate, CH3COOH will dissociate as CH3COO minus plus H plus. Correct? H plus is not only coming from acetic acid, this H plus will be coming from HCl also. So HCl is breaking and giving you H plus plus Cl minus. So there are two sources of H plus ion concentration, correct? But we know HCl is a strong acid compared to acetic acid. So H plus coming from HCl will be dominant compared to that of acetic acid. So we have H plus from HCl will be more compared to H plus from CH3COOH. This is the basic terminology that I am using. So concentration of H plus in the given question will be determined by HCl, not from acetic acid. Because we know when we have got two acids given in a particular medium, H plus ion concentration will be dominated by the acid which is stronger. Correct or not? Right, children. Let us see the dissociation of this acetic acid respectively. So let us remove it off for some period of time. So let us see dissociation. So you understood HCl from H plus from HCl will be more. So let us suppose we have 1 mole started and from there X moles are breaking. I'll directly take the equation into consideration because we know now no initial concentration, C concentration after time T equilibrium concentration. 1 minus X at time equals to T seconds. Already H plus from HCl is how much? According to the given question, how much molar? 0.1 molar, right? And this H plus is also coming from acetic acid. So it will be X. This will become 0.1 plus X respectively. So concentration of H plus will be X plus 0.1 molar because 0.1 from HCl and X is coming from acetic acid clearly. Right, children? Good. Now we know Ka, dissociation constant of acid. What is it equal to? It's equal to molar concentration of products by reactants. So what can I write down? It is X into X plus 0.1 divided by 1 minus X, molar concentration of reactants. Is it clear? So we can neglect this x with respect to 0.1. Can we? Because x is coming from where? Acetic acid, which is very less. So we can neglect this x in numerator and denominator and numerator. What does the equation become? We will have Ka equals to, what's it? X. This one can be neglected or not? Yes or no? What are we searching out for? We are searching for the value of Ka. So we have the denomination of what? Concentration 1. I have taken 1 mole into concentration, right? But what is the molar concentration of acetic acid given to you? 0.01. So instead of writing that 1 here, I can take 0.01 into concentration. So this will be x here. Or yes or no? So it will be x plus 0.1 molar. So here it will be again 0.01 minus x. Clear or not? So can we neglect x with respect to 0.01? So what does it become? So K will be equal to x into, this can be neglected? Yes or no? X will be x 0.1 divided by, so with respect to 0.01 we can neglect x because that's very less, amount of this dissociation is very less. So we have 0.01. Clear? K is given or not? What is K value given to you? 1.8 10 to the power minus 5. So 1.8 into 10 to the power minus 5 into, take it here, 1 into 10 to the power minus 2 divided by 10 to the power minus 1 equals to x. Am I clear with the thought here? Yes, it goes up, it becomes 1.8 into 10 to the power minus 5 minus 2 will be minus 7. It becomes minus 6. So x equals to 1.8 into 10 to the power minus 6. Is it clear? We have to find out percentage degree of dissociation. So here x I have taken, degree of dissociation. Tell me, what is degree of dissociation equal to? So we can take degree of dissociation, that's alpha. What's that equal to? Number of moles dissociated divided by number of moles taken. So what's the number of moles dissociated? X. Or is it or not? Divided by what's the number of moles taken? 0.01, because you have taken 0.01 molar concentration of what? CH3COH. So x divided by 0.01. Clear or not? Or is it clear? Into 100. That will give you percentage degree dissociation. So percentage alpha will be equal to x. What's the value of x I got here? 1.8 into 10 to the power minus 6. Right? Divided by 1 into 10 to the power minus 2 into 10 to the power 2. So percentage degree of dissociation will be 1.8 into 10 to the power minus 6, 2 will be minus 4. It goes up, what does it become? Minus 2 goes up, it becomes plus 2. This one and this one will be off or not? 10 to the power minus 2, when you take it up, it becomes plus 2, it becomes 4. Clear? So minus 6 minus 4 will be, minus 6, 4 becomes how much? How much? Minus 2. So alpha will be 1.8 into 10 to the power minus 2. Can I say 1.8 divided by 100? Can I or not? So that will further be equal to what? 1.8 divided by 100 is how much? Faster, calculate it out. It will be 0.018%. Is it correct? So it is 1.8. Can I take it 18 by 1000? Right. So it will be point, then 0, then 1, then 8. So it will be 0.018% will be the degree of dissociation respectively. You got the question clear? So question was asking us, we have been given 0.01 moles of acetic acid. It is giving H plus. H plus is also coming from HCl. So concentration of H plus from HCl will be a dominating term for us. So I neglected the terms of what? X with respect to 0.1, x with respect to 0.01. So our final equation for x was equal to 1.8 10 to the power minus 6. But x is what? The number of moles dissociated. But what is degree of dissociation? Number of moles dissociated by number of moles taken. So x divided by 0.01 into 100. That will be percentage degree dissociation. On solving, you are getting 0.018% degree dissociation. Is it clear, children? Right. Move to the next question now. So next question is asking us, at 100 degrees centigrade, Kw equals to 10 to the power minus 12. So question is, at 100 degrees centigrade, Kw equals to 10 to the power minus 12. So question number 2, at 100 degrees centigrade, Kw is 10 to the power minus 12. Okay, good. pH of pure water at 100 degree will be, so pH of pure water at that temperature will be, options that has been given to us are 7, 6, 8, 12. It is 7, option 2 is 6, option 3 is 8, and option 4 is 12. These are the 4 options given to you. We know, children, the only thing that can alter the equilibrium constant is temperature. So we know at 25 degrees centigrade, ionic product of water is 10 to the power minus 14. What is ionic product equal to? The product of molar concentration of H plus and OH minus, which is 10 to the power minus 14. So H plus technically is 10 to the power minus 7 molar. And also OH minus is 10 to the power minus 7 molar. But we have increased the temperature from 25 degrees centigrade to 100. So naturally, the ionic product will increase or decrease. It will obviously increase. But when ionic product is increasing, what is ionic product equal to? H plus into OH minus. So on increasing the temperature, it is equal to now 10 to the power minus 12. That means H plus will be equal to 10 to the power minus 6. So what is pH equal to? It is negative log of H plus ion concentration. So that will make it negative log of 10 to the power 6. 6 log 10, that will make it 6. So what will be the pH? Option 2 will be the correct option. So we'll have 6. Now you might think, sir, does it mean that when you're increasing temperature, water becomes more acidic? Obviously not. Because if pH is 6, that means pOH also will be 6. So pH plus pOH is on the whole equal to 12 here, not 14. Because we have increased the temperature, so the value has increased from 10 to the power minus 14 to 10 to the power minus 12. So remember, whenever you are solving questions of ionic product with respect to temperature, increase of temperature will definitely increase the value of Kw. And keep it in mind, decrease in negative means increasing. So from 10 to the power minus 14 is going to 10 to the power minus 12. So correct option will be 6. That's option 2. Right, children? Next question. A solution of NaOH contain 0.04 grams of NaOH per liter. Its pH is. So question number 3 is, solution of NaOH contain. So we have a solution of NaOH. It contains 0.04 grams of NaOH. Very good. So it is pHs per liter, 0.04 grams per liter. Okay. So what will be the pH of the resultant solution? That's a question which has been asked to us. Options are 10, 9, 11, 12. So options are 10. Second option is 9. Option third is 11. And option fourth is 12. These are the options given. 10, 9, 11, 12. 10, 9, 11 and 12. Very good. Now this is sodium hydroxide, correct? Because this is sodium hydroxide, so obviously its pH has to be above 7. So all the 4 options which are given to you are above 7. So you cannot directly solve this question. We need to sort it out and solve it out. First of all, children, when NaOH will break, what does it give me? It will give me Na plus plus OH minus. If I am able to find the OH minus concentration, molar concentration of OH minus. If I found OH ion concentration, I can find out pOH. Once I am done with pOH in aqueous medium, pH plus pOH equals to 14. Once pOH is done, I can easily calculate pH. Clear? That's a basic fundamental rule behind this question. So we have been given mass. So what we will do is, we will see what is the number of moles of NaOH that are given to us. Clear? So let us solve this question, children. So come back here. We'll solve this question out. Right. So we'll see 0.04 grams of NaOH. Let us see moles of NaOH. What are the moles of NaOH, children? What is moles equal to? Mass divided by molar mass. So what's the mass here? 0.04 grams is the mass divided by. What's the molar mass of sodium hydroxide? It is 40. grams per mole. Correct or not? So grams will go off, mole will come up, it will be the moles of NaOH for us. So that implies, so it is 4, yes, into 10 to the power minus 2 by 4, it becomes 10 to the power 1 goes up, it becomes minus 1. So this will be off, it becomes 10 to the power minus 3 moles. So children, what is the molar concentration of sodium hydroxide that is given to us? It's 10 to the power minus 3 moles. Correct or not? Right. Let us see. So sodium hydroxide, how many moles are there? 10 to the power minus 3. When it breaks, what does it give me? 10 to the power minus 3 molar of Na plus and 10 to the power minus 3 moles of OH minus. Correct or not? So find out POH now. POH will be negative log of OH minus ion concentration, which is negative log of 10 to the power minus 3. So 3 log 10, it will be, POH will be 3. POH is 3. What is pH equal to? 14 minus 3. That makes it 11. So correct option will be option 3rd. Did you get it? So mass was given. I converted mass into moles and then used the equilibrium equation for solving this question. We have solved it in chemical equilibrium already. Ice calculations we have done. So dear, whatever the rules you are employing, you have to use same rules. The only thing is, we are not in need of finding out total number of moles. Moles at equilibrium, all those things here. Because our main discussion is with respect to pH, POH, Kas, buffers, acids and bases, and solubility products in ionic equilibrium. Is it clear? So correct option will be option 3rd. Right. Let's move to the next question, children. I'll just start this question directly, which is the pH of solution is 0. What's the pH of solution? It's a direct question. So you can solve it out. Question number 4 here. pH of solution is 0. Okay, good. What is the solution? Options are neutral, option 2 normal acid, third is decinormal acid, and fourth option is strongly alkaline. Very simple. What is pH? 0. So what is pH equal to, children? Negative log of H plus ion concentration. So what will be H plus ion concentration? 1. So what do you get? It's a normal acid. So correct option will be 2. Yeah, simple, direct question. Next question. We have 100 ml of 0.1 normal NaOH is mixed with 100 ml of 0.1 normal H2SO4. Very simple. 100 ml of 0.1 normal HCl and 100 ml of 0.1 normal H2SO4, not molar. If it is molar, we need to change it, right? Because it is normal solution, so the gram equivalence of the acid will be equal to the gram equivalence released by the base. Yes or no? So when you mix the equal volumes of both, what will be the gram equivalence of H plus and OH minus in the solution? Same or different? Same. Solution will be alkaline or neutral or acidic. It will be neutral. So question is simple. So question number 5 here. It is what, children? We are mixing 100 ml of 0.1 normal NaOH and 100 ml of 0.1 normal H2SO4. We are mixing the two. What is the pH of the resulting solution? Options are less than 7, option 2 more than 7, option 3 equal to 7, and option 4 cannot be predicted. Obviously option will be 7. Why? Because 0.1 normal of NaOH will give you how many moles of OH? It will give 0.1 gram equivalents of what? OH minus. And 1 normal, 0.1 normal H2SO4. If it is 0.1 molar, it will give 0.2 normal, right? So if it is 0.1 normal, it will give you how many moles of H plus? Again, 1 gram equivalent of H plus. This is also giving you 1 gram equivalent of OH minus. So 1 gram equivalent of H plus will combine with 1 gram equivalent of OH minus to result in the formation of 1 mole of water. So what will remain? H plus will remain or OH minus? None of this. Solution will be neutral. That means correct option will be option 3. Good. Question next. Question is a simple one, so you can solve it. The pH of 0.016 molar NaOH solution should be able to solve this question quite easily, children. So we'll move on to the next question. Question is, the following reactions are known to occur in the body. So what's a reaction that's occurring in the body? So question number 6 we have. It is CO2 plus water is in equilibrium with carbonic acid, that is H2CO3, which is in equilibrium with H plus plus CO3 HCO3 minus. Okay. If CO2 escapes, so CO2 is escaping from the system, right? Then which of the following options will occur? Which of the things will occur technically? pH decreases. This is first option. Second option, H plus ion concentration will diminish. Third option, H2CO3 will be promoted. What does it mean? H2CO3 concentration will increase. And fourth one, forward reaction will be favored. So forward reaction proceeds. Good question. Now, the following reactions are known to occur in the body. If carbon dioxide is escaping, the 4 options are given to you. Let us see. So here, according to question, the systems are in equilibrium with respect to each other, right? So we can easily use Leachate's principle for this purpose. So what does Leachate's principle say? A system alters in concentration. If you decrease concentration of one of the two sides, it will try to increase that. Suppose, in the present case, carbon dioxide gas is escaping out, right? Because H2CO3 is in equilibrium with carbon dioxide and water, CO2 is escaping. According to Leachate's principle, to maintain equilibrium constant because temperature is not altered, only concentration is being changed. So to keep the value of K constant, because if you find out the K value here, K will be H2CO3 divided by molar concentration of CO2 and molar concentration of water. So CO2 is decreasing. When CO2 decreases, obviously K will increase. But we are not altering temperature. So the value of K should remain constant. For that purpose, if CO2 is decreasing, H2CO should also decrease. So to replenish the amount of CO2, thus equilibrium constant will go back to the original value. So when CO2 escapes, there will be backward reaction promoted. That means CO2 will be produced more. Now, when H2CO3 is being reduced, because it is converted to carbon dioxide, it alters this equilibrium, right or not? So what it will do is that H plus and HCO3 minus, which will combine with, H plus will combine with HCO3 minus to produce more and more H2CO3. So the reaction will be going like this, going towards backward direction and going towards backward direction. As a result of that, what will happen to H plus ion concentration? It will decrease. So when H plus ion concentration decreases, pH will increase, right? Because solution will become less acidic. So when H plus is diminishing, pH should increase. But here pH is decreasing. This is wrong option. H plus will diminish is a correct option. H2CO3 is promoted. That means there is more and more production of H2CO3. Obviously not, right? And the reaction occurs in which direction? Forward direction. 100% it's not happening. So the correct option is H plus will be diminishing. So this is a direct application of which principle? Leachate's principle in human systems. Is it clear, children? Good. Right. Let's move on to the next question, children. So correct option is hydrogen ion concentration will diminish. Means it will decrease. Right. Let's see the next question. So read the question and see the things properly, what exactly we are discussing about. Next question is, children, question number 7. The solubility product of AgCl is KSP. So for AgCl, we have been given solubility product as KSP. Okay, good. Then the solubility of AgCl in X molar KCl then the solubility of same AgCl in X molar KCl. This is important question, and a common ion effect will be working here. So let us write the options first so that we can move forward. Options are Ksp into S square. Option 2 is X by Ksp. Option 3 is Ksp by X square. And option 4 is Ksp by X. This is a question which is asking us, right? Let us see. So AgCl when breaks, what does it give you? It will give you Ag plus plus Cl minus, right? Now children, KCl is also breaking because one of the ion is common, which is Cl. It will give you K plus plus Cl minus. So the common ion here is chlorine. Both of these electrolytes are producing chlorine, but we know silver chloride is a sparingly soluble salt. It means its dissolving tendency is very less because latest enthalpy of AgCl compared to hydration enthalpy is bit high. But KCl is a strong electrolyte. It dissociates very quickly. So the amount of Cl coming from KCl is how much? X, because K will be X and Cl will be X. So let us write that X. Clear or not? And from AgCl, let us suppose the solubility of chlorine is S. So if it is 1 mole, it will be 1 minus S. Amount of solubility is a term of concentration, which is used for sparingly soluble salts. Clear? So 1 minus S. This will be S. This will be S plus X. Why? Because this chlorine is coming from KCl as well. So it will be S plus X. Am I clear here with the thought? Or clear? What am I asked you to find out, children, is then the solubility of AgCl in X molar KCl will be. So have a look here. We will have, what is solubility product equal to? Ksp will be equal to, because this is solid, in denominator we neglect it out. So Ksp will be equal to S into S plus X. Right? Very good. So what is the solubility product of AgCl given to you? It is Ksp only. Will be equal to S square plus Sx. S square plus Sx. What is the S? Solubility of what? AgCl. But the amount of S coming from AgCl, that is chlorine coming from AgCl, is less or more? Very less. So I can neglect it with respect to X. So S square can be neglected. What can we write down? Ksp will be equal to Sx. So what will be solubility of AgCl in X molar KCl equal to? What is that solubility equal to? S. So what will be S equal to? It will be equal to Ksp divided by X. So the correct option will be the fourth option. If you follow the protocol here, simple. AgCl solubility product is Ksp, and it is being dissolved in the medium which already contains KCl, X molar KCl. So chlorine is coming from two different salts. It's coming from AgCl, it's coming from KCl. The amount of chlorine coming from KCl will be more compared to that of AgCl. So from AgCl, the chlorine coming is S, but from chlorine from KCl is X. So I can easily neglect S square with respect to Sx. Yes, because X is higher in value, Sx cannot be neglected, but S square can be easily neglected with respect to Sx. If there is no strong electrolyte, then you have to take this S into consideration here. Clear? So S is neglected out. So Ksp becomes equal to Sx. S will be equal to Ksp by X. So the correct option will be fourth option. Did you follow it or not? Solubility finding out means simply you are finding out amount of that ion. When you say that ion, it means the whole salt that is dissolved in presence of other ion. Naturally, children, according to common ion effect, a system which contains weak electrolyte, and to that you are adding strong electrolyte. What happens? The degree of dissociation of the weak electrolyte is suppressed. What does it mean? There is more and more formation of that weak electrolyte because reverse reaction comes into play. This is a basic rule of buffers as well. Clear? Excellent. So what is the correct option, children, for us? Correct option will be S equals to Ksp by X, option 4. Next question. So we have the next question now, so you can keep a track of the question. So we have question number 8 now, children. That again will be with respect to solubility product only, right? Because there are some very, very important subtopics in our ionic equilibrium where short questions in examinations do come. So please have a repetition of this equilibrium, and if you understand the protocol of the questions of chemical equilibrium and ionic equilibrium very well, you will be very well versed with equilibrium respectively. Clear? Yes. Let us see the next question. The KSP for a sparingly soluble Ag2CrO4 is 4 into 10 to the power minus 12. So for sparingly soluble, this question number 8, almost 9, because I told you one question to do at home. So next question number is KSP of sparingly soluble salt Ag2CrO4 is how much? So it is KSP value is given how much? 4 into 10 to the power minus 12. Good. What is its molar solubility? So technically you are calculating S. Now you can see that, children, this is A to B type of salt, and we know solubility product equals to what? It equals to, for A to B type salt, solubility product for Ag2CrO4, when it breaks Ag2CrO4, it will give you 2Ag plus CrO4 2 minus. Clear? Clear or not? So let us suppose it is 1 minus S. This will be 2S. This will be S. Raised by the power equal to their stoichiometric coefficients. So what will be KSP equal to, children? It will be 2S whole square into S. Right? So KSP will be equal to 4S cube. Am I clear with the thought here? So what do you need to find out? We need to find out molar solubility of the salt. Very simple. We have to find out S value. So KSP. So we can write down KSP divided by 4 equals to S cube. What is KSP? 4 into 10 to the power minus 12 by 4 equals to S cube. Am I right here? So this will be of 1 into 10 to the power minus 12, and cube root of this will be equal to S. So S will be 10 to the power minus 4. So solubility is 10 to the power minus 4. So what are the options that are given to you, children? 10 to the power minus 4 moles per liter. Options that have been given are: first option 2 into 10 to the power minus 6 moles per liter. Second, it is 1 into 10 to the power minus 4 moles per liter. Third, 2 into 10 to the power minus 12 moles per liter. And fourth option, children, is 1 into 10 to the power minus 15 moles per liter. So correct option is option 2. Did you understand this out clearly? Because for a ternary salt which contains A2B type or AB2 type, 4S cube. Am I clear? Because here it is, see, it is twice Ag, right? So if I suppose solubility of CrO4 is S, then Ag will be S into 2, raised by the power equal to stoichiometric coefficient. So 2S whole square, S, it becomes 4S cube. Then you can solve the question and get it done. Clear? So correct option will be 10 to the power minus 4. Right? Very good. Next question. An example of salt dissolved in water to give acidic solution is. So we have a salt given here, and we need to find out which of the following solutions will be acidic. What is the basic rule, children, to find out whether the given salt solution will be acidic or basic or neutral? Simple. I will tell you the scenarios there. So we have question number 9, almost question number 10 here. Question is, example of salt dissolved in water to give acidic solution. So I am finding out acidic solution. So options are ammonium chloride, NH4Cl, ammonium chloride. Option 2 for you is sodium acetate, that is CH3COONA. Actually here in the given question it is written in terms of language, ammonium chloride, sodium acetate, and I am writing it down in terms of potassium nitrate, third KNO3, and fourth one that is given to us is barium bromide. So BaBr2, barium bromide, right? So this is ammonium chloride, sodium acetate, potassium nitrate, barium bromide. So I'll write it down. Barium bromide. Then you have potassium nitrate. Then you have all those things. All right. Now look here. In order to find out acidic solution of a given salt, what do we need to find out? Strong acid, strong base. The salt solution will be neutral. Strong acid, weak base. Weak base will give less OH. Strong acid will give you more H plus. When neutralization will occur, what will remain there? H plus. Solution will be acidic. When we have a strong base and a weak acid, what will remain more? OH. Solution will be basic. Am I clear with the thought here or not? Solution will be basic. And if you have a weak acid, weak base, you need to see the values of K. Usually, weak acid, weak base will be a neutral solution, but you need to find out the values of K. If K of a weak acid is more than Kb of a weak base, then the dissociation of acid will be more than base. Solution will be slightly acidic. Clear? So tell me, ammonium chloride will be made by ammonium hydroxide plus HCl. What is this? It's a weak base. This is strong acid. Yes? So strong acid and weak base. Less OH minus, more H plus. Once neutralization occurs, what will remain more? H plus. Solution will become acidic. So salt to solution will be acidic. This is correct option for us. Let us see this one. CH3, COOH plus NaOH. This is strong base. This is weak acid. Less of H plus, more of OH minus. So pH will be more or less. pH will be more. That is H plus ion concentration is less. That means OH will be more. KNO3, you can take it potassium hydroxide plus HNO3. This is strong base, strong acid. It will be perfectly neutral solution. Barium bromide, it can be made by barium hydroxide and it can be made by HBr. You can see that these things very clearly. So the correct option for us is the first option. That is ammonium hydroxide and HCl will give you the salt solution which will be more acidic. Am I clear, children? Am I clear here or not? Yes? Excellent. So we continue on our next questions. Right, our question is the number of hydrogen ions in 10 ml of solution with pH 13. So in 10 ml of solution whose pH is 13, what is the number of H plus ions? That's a question. So our options are, so option 1, 10 to the power 13, option 2, 6.023 into 10 to the power 8, option 3, 6.023 into 10 to the power 10, and option 4, 6.023 into 10 to the power 30. Now in this question we are asked to find out in 10 ml of solution the number of H plus ions. So in 10 ml naturally it's not possible to have Avogadro's number because in 10 ml you cannot have Avogadro's number of particles, right? So we have Avogadro's number of particles in 1 liter, that is 1000 ml will contain 1 mole of H plus ions. That's a basic logic we all understand. But our question given is in 10 ml. So first of all, let us find out what is the H plus ion concentration that is given to us. That means what is H plus ion concentration per liter which is given. Directly it is not given. We have been given pH equal to 13. That means H plus ion concentration will be 10 to the power minus 13. Is it clear? So you got H plus ion concentration 10 to the power minus 13. That is 10 to the power minus 13 moles of H plus are present in 1 liter. Right? We can write it like this. 1000 ml contains 10 to the power minus 13 moles. Clear? So moles is Avogadro's number. So that is, what about 1 ml? It will be 10 to the power minus 13 by 1000. And what about 10 ml, children? 10 to the power minus 13 by 1000 into 10 into Avogadro's number. Clear? Because you have the moles concept here. What's a question that they are asking us? What is the number of H plus ions? So you got 10 to the power minus 13 moles into Avogadro's number. So 10 ml will contain 10 to the power minus 13. It will be 10 to the power 3. Above it will be minus 3. It is 10 to the power 1. Yes or no? So we'll write down into 10 into 6.023 into 10 to the power 23. minus 13 minus 3 will be 10 to the power minus 16. It is plus 23. So the order will be 16 plus 10, 26. What will be the value close to? It will be almost 8. So the correct option will be 6.023 into 10 to the power 8. So you can multiply it by 10, you can get the respective value. Did you get it? So 10 ml will contain 6.023 into 10 to the power 8. Clear? 1 liter will contain 10 to the power minus 13 moles. That's Avogadro's. 1 liter contains 10 to the power minus 13 Avogadro's number of particles. So that is rest calculation that has been seen by us clearly. Yes? Very good. Question number next. In the following reaction, so we have almost question number 11 here. So the reaction given to us is, children, HC2O4 minus HC2O4 minus plus PO4 3 minus, PO4 3 minus is in equilibrium with what? HPO4 2 minus, so this will be plus C2O4 2 minus respectively, all in aqueous solutions. Which pair can act as Bronsted bases? So out of this, which pair is Bronsted base? Yes. So we have three concepts of acids and bases: Lewis concept, Bronsted-Lowry's concept, and Arrhenius concept. According to Bronsted-Lowry's concept, anything that's able to release H plus is acid, and anything which is able to accept H plus is a base. Our question is a pair of Bronsted bases. So the options that are given to you are HC2O4, HC2O4 minus, and PO4 3 minus. Option 2 is HPO4 2 minus and C2O4 2 minus. Option 3 for you is HC2O4 minus and HPO4 2 minus, HPO4 2 minus, and fourth option for you is, children, PO4 3 minus and C2O4 2 minus. Now we have a concept in Bronsted-Lowry's acids and bases that any system which can release a proton is an acid. Any system which can release as well as accept is an amphoteric substance. Clear? And anything which can only accept an electron pair, accept a proton is a base. Now our question is a pair of Bronsted bases. Now if you look on H2CO4, it can donate out a proton, so act as acid. So this option cannot be correct because H2CO4 can act as acid as well. It can act as base also. So it can get converted to H2C2O4. Right? So this is amphoteric in nature. This can only act as base, but we have a pair. So this is not acting as only acid. It can act as a base also. So this is the wrong option. Now HPO4, obviously it can act as acid, right? And it can act as base also by gaining an electron, by gaining a proton to become H2PO4 minus. So this also is the wrong option for us. Third, obviously again the same thing, right? Because it contains both of these. So both are amphoteric in nature. They are both amphoteric. This is amphoteric. This is base. This one is amphoteric again. This can act as only base. Here both can act as amphoteric substances, right? Both acid and this is the one which can only act as a base. You can see that PO4 3 minus can accept a proton and C2O4 only can accept a proton. There is no proton, so the release of proton is not possible. Thus they cannot act as amphoteric substances. They cannot act as a bases, acids as well. The only thing they can act as will be base. So PO4 3 minus and C2O4 2 minus is a correct option for this. Clear, children? So which option is correct? Option 4. Right. Next question. Question is the pH of 10 to the power minus 11 molar HCl. So this is question number 12. 10 to the power minus 11 molar HCl pH we have to calculate. Options are 1, 11. Option 2 is 3. Option 3 is slightly greater than 7, and option 4 is slightly less than 7. Let's look on this question, children. So our question is, what will be the pH of 10 to the power minus 7 molar HCl. Right? So according to basic logic, when you look on HCl, it's an acid. It will be highly diluted acid because the amount of water added to this HCl is huge. That's why H plus ion concentration is extremely less. But because it is HCl, its pH cannot be more than 7. Acid's pH will be below 7. Here it is highly diluted. So its pH obviously is not possible to be more than 7. Thus, 11 cannot be our correct option at all because this will be base for us. Number 2, it is 3. If it is 3, then H plus ion concentration should be enormously high. But this is highly diluted acid, so pH 3 having the possibility of pH 3 is also not possible. So this is also a wrong option for us. Now it is slightly more than 7, obviously wrong option because this is acid, cannot have pH more than 7. So the correct option will be slightly less than 7. Direct options you can solve it out. Now let us see it mathematically. How do we solve the question? Here it is 10 to the power minus 11 molar HCl. When it breaks, it will give you 10 to the power minus 11 molar H plus and 10 to the power minus 11 molar Cl minus. But I need H plus. So pH equals to negative log of H plus ion concentration. So that is negative log of 10 to the power minus 11. That will make it 11. So according to solving of pH negative log of H plus, you are getting first option as correct option, but that's a wrong option. Because children, remember that whenever you have highly diluted acid with the addition of water, we already know ionic product of water is H plus into OH minus, and we already know it, H plus ion concentration coming from water is 10 to the power minus 7 molar. So you have H plus ion concentration 10 to the power minus 7. Now if you look on H plus from HCl and H plus from water, you have H plus coming from water to be more compared to that of HCl. So in this case, whenever you have an acid or a base given to you in which the H plus or OH minus ion concentration of water cannot be neglected. Suppose if from acid it was 10 to the power minus 3 molar H plus, you can easily neglect 10 to the power minus 7. However, if it is 10 to the power minus 6 or minus 7 or minus 8, this cannot be neglected with respect to 10 to the power minus 7. If H plus from water is, which is 10 to the power minus 7, and from acid it is like 10 to the power minus 5, you can easily neglect water. But it is 10 to the power minus 11, you cannot neglect water here. So what you have to do is you have to sum up both H plus ion concentrations, both from HCl as well as from water in that case. So it has to be under additive effect. So pH, children, will be equal to negative log of H plus from HCl plus H plus from water. So because we cannot neglect H plus from water compared to HCl. If HCl is strong acid which is not diluted, then you can neglect water very easily. So it will be negative log of 10 to the power minus 11 plus 10 to the power minus, that is 1 into 10 to the power minus 7. On solving this equation, you will definitely get slightly less than 7. So correct option will be fourth option. Did you get it? So remember this, children. So when you have got acid or a base highly diluted and the amount of H plus from water, which is 10 to the power minus 7, H plus 10 to the power minus 7, OH minus, cannot be neglected. You need to bring the additive effect into consideration. Clear? Clear or not? Yes. Next question. Question is, the pH of M by 100 CaOH2 will be. So we have this question number now 13. pH of M by 100 CaOH2. So this is your homework. You can do it. It should be simple. M by 100 means 0.01, and 0.01 molar calcium hydroxide will give you 2 into. Let us solve this out. So what are the options? Options are 1.699. I will write down the options here, children. So what's the question number 13? We have to find out pH of M/100 calcium hydroxide solution. pH of, question number 13, pH of M/100 CaOH2 solution, right? Options are 1.699, option 2 is 12, option 3 is 12.301, and option 4 is 12.699. We have to find out pH, right? So because this is a basic solution, pH will be above 7, so this is not correct option. So these two are possible options for us. Let us see how much will come into play. Now when calcium hydroxide, children, breaks, it will give you Ca2 plus 2 moles of OH minus. M/100 means 1/100 molar concentration, that means 0.01. So you got 0.01 molar concentration of calcium hydroxide. It will give you 0.01 of calcium and 2 into 0.01 of OH minus. So OH minus ion concentration is 0.02. That is 2 into 10 to the power minus 2. Am I clear here? Very good. So we have to find out what is POH here, equal to negative log of 2 into 10 to the power minus 2. So that will be 2 log 2. So 2 minus, what is log 2 equal to? 0.304 most probably, and it will come equal to almost 1.7. So what is POH equal to 1.7? What will be pH equal to? 14 minus 1.7, because children, pH plus POH equals to 14. So what will be the correct option for us? Option 3 will be correct option. That's 12.301 will be correct option for us. Am I clear? So here the thing is that you have to multiply it by 2, calculate POH, then pH plus POH is equal to 14. You can solve the question then. Clear? Very good. Move to question number 14. 2 samples of CH3COH, each of 10 grams, were taken separately in 2 vessels containing water of 6 liters and 12 liters respectively at 27 degrees centigrade. The degree of dissociation of CH3COOH will be. Now we have taken 2 samples of, question number 14, 2 samples of CH3COOH. I'll take 2 samples of CH3COOH. Temperature for both is 27 degrees centigrade. So remember, equilibrium constant, that is dissociation constant, is not going to change. It will remain constant. Now this one is being put in the volume of, in a vessel which contains water of how much? This contains 6 liter volume capacity and this contains 8 liter volume capacity. Okay, good. Temperature same. The degree of dissociation of CH3COOH will be, what will be alpha of CH3COOH? While it will be more. So we have the options. More in 12, so we don't have 8 liters, we have 12 liters here. So it is more in 12 liters, B. It is more in 6 liters, option 3. Equal in both, and option 4. Half in 6 liter vessel, then in 12 liter vessel. So it is half in 6 liter vessel, then 12 liter vessel. So it is half in 6 liter vessel, then 12 liter vessel. So I am writing directly, quickly. Now children, naturally, so when we are in, this is a weak acid. What does Ostwald's dilution law tell us? Direct statement. Ka equals to C alpha square. We know it out. Divide by 1 minus alpha. Alpha with respect to 1 is negligible, so we can neglect it. So Ka equals to C alpha square. Here you have been given 12 grams for both. Let us say 12 grams, which is not actually equal to. So let us say 12 grams of both have been taken. So equal mass, right? Mass by molar mass will be same. So number of moles of both are same. Let us say we have taken 1 moles of both. Concentration is 1 mole. We know concentration equals to number of moles by volume. So this Ostwald's dilution law actual statement can also be written as K equals to alpha square by V. Clear? Now look on the case. So children, dissociation constant is dependent on temperature, equilibrium constant. Is it changing? Is temperature changing? No. So directly you can say, sir, when the volume is more, dissociation will be more. That's a direct way to solve the question. But children, we should understand how we are reaching the conclusion here. Correct? Even in electrochemistry, all of you have read that for a weak acid, when you are increasing the amount of dilution, the degree of dissociation will increase. However, if the degree of dissociation is increasing, we should expect that weak acid should also conduct equal to that of strong electrolyte, strong acid. That won't happen because the dilution factor of a weak acid is very large and number of moles per unit volume will be very less, so conductivity will be less. Am I clear? Good. So K equals to alpha square by V. Now, in case of second option where there is 12 liters, what we are doing to volume? Increasing, that's 12 liters. So when V will increase, naturally K will decrease, but K should remain constant. In order for K to remain constant, the numerator alpha, which is degree of dissociation, should also increase. And when degree of dissociation will increase, K will come back to the original value. So here volume is less. When volume is less, K change will be less. There will be change, but the change in K will be less. To replenish the change, degree of dissociation will occur. It will increase, but it won't increase how much it has increased in 12 liters. So this is why we call this statement also as dilution law, because when you take volume into consideration, it becomes an important parameter. And one more thing, in electrochemistry, all of you should be knowing, and all of you will be knowing, alpha is calculated how? Lambda m divided by lambda m naught. Molar conductivity at a particular dilution by molar conductivity at infinite dilution. Because at infinite dilution, we consider 100% dissociation. That means number of moles taken. Right? Correct. So you can relate out this asked about the dilution law statement with this as well. So correct option will be degree of dissociation will be more in 12 liter vessel. Yes or no? Clear. Good. Question number next. So we have question number almost 16 or 15. So you can see the order. So what's the question asking you? When a small amount of HCl is added to a buffer solution of acetic acid, the sodium acetate. Let us solve this up, children. Yes, children. Let us see the question. This question with respect to buffers. When a small amount of HCl is added to a buffer solution of acetic acid and sodium acetate. So we have a buffer solution of acetic acid, that is CH3COOH, which will give you CH3COO minus plus H plus, and sodium acetate, that is CH3COONA. Because we know buffer is made up of weak acid and it is strong electrolyte, it will give you CH3COO minus plus Na plus. Good. Right. Now this is the solution we have, buffer solution. To this solution, we are adding small amount of HCl. So we are adding small amount of HCl. What will HCl break into? H plus plus Cl minus. Okay, good. So when small amount of HCl is added to this buffer solution, what happens? Number one, pH increases. pH increases. Option 2, H plus decreases. H plus ion concentration is decreasing. That means pH is increasing. Third one, dissociation of acetic acid decreases. Third one, dissociation of acetic acid decreases. And fourth option is CH3COO minus increases. CH3COO minus concentration is increasing. Now this question is with respect to common ion effect. A very simple way to tell it. So we have this buffer solution. To this buffer solution, you are adding an electrolyte which is furnishing one of the ion common. So what is the common ion added to here? HCl. Now we know, children, there is no backward reaction possible for sodium acetate because alpha value is equal to 1. This is a strong electrolyte, it will break completely. And you will get acetic acid and Na plus molecules. Now you are adding HCl. Due to that HCl, H plus ion concentration will be increasing. So that means this H plus ion concentration, which is on the right side, means product side, this is increasing by the addition of H plus, right or not? according to Leachate principle, there is an equilibrium existing in this reaction, right? So you are increasing one of the two molecules participating in the reaction. So you are increasing products. What happens? In order for this H plus to decrease, this H plus can combine with CH3COO minus and backward reaction will occur. In the second case, backward reaction is not happening. In first one, there's a backward reaction. Once backward reaction occurs, you will get more amount of CH3COOH. So technically what is happening? The dissociation of CH3COOH is reducing. So when it is dissociation is decreasing, that means its concentration will be increasing. So correct option will be dissociation of acetic acid will decrease. Now what's the question telling you here? H plus is decreasing. No, you are adding H plus. Due to addition of H plus is increased. There will be no change in the concentration of H plus. See, once you added H plus ion concentration increased. To bring this value back to the original value, to bring this H plus back to the original value, original pH, it will use some H plus and that will combine with acetate ions and it will result in the formation of acetic acid. So there is more and more formation of acetic acid. Thus, the degree of dissociation of weak electrolyte is reduced. That's what common ion effect is. When you are adding a strong electrolyte to a system containing a weak electrolyte, when weak and strong electrolyte both are furnishing a common ion, then the degree of dissociation of weak electrolyte is suppressed. Degree of dissociation suppressed means its formation is increased. So correct option will be dissociation of acetic acid will decrease. Am I clear, children? Right, very good. Let's move further forward. So this question will be with respect to solubility product. Question is, at 30 degrees centigrade, the solubility of Ag2CO3 KSP is given, would be minimum in 1 liter of, would be maximum in 1 liter of. So we have been given, so this is question number 14. Please check the tables properly, what the question number may be. Question numbers are here and here. So at 30 degrees centigrade, temperature is not changing. KSP for Ag2CrO4 is given. How much? So Ag2CO3 is given how much? 8 into 10 to the power minus 12. Question is, solubility of this Ag2CrO4 will be maximum in, we have been given, options are 1, maximum solubility will be 0.05 molar Na2CO3, second 0.05 molar AgNO3, third one pure water, and fourth one 0.05 molar ammonia. Now we have been given Ag2CO3 with solubility product 8 into 10 to the power minus 12, correct? Our question is, Ag2CO3 is being added to these 4 solutions. Where will the solubility be maximum? Very simple. Now you see here, Ag2CO3 will furnish 2 ions, silver and carbonate, that is CO3 2 minus. Now, when you are taking molar concentration of all these, it is same, correct or not? Good. So it is releasing sodium carbonate. So look here, when you dissolve this in Na2CO3, you already have 2 moles of sodium plus CO3 2 minus. So there is already in the solution, in the given solution to which you are adding it, it already has carbonate ions in it. So and when Ag2CO3 will break, it will also give CO3. CO3 is already there. And when you are adding Ag2CO3, it will also furnish CO3. How much could be dissolved in absence of CO3 will not be same. So the amount of Ag2CO3 dissolving in Na2CO3 will be less. Did you get the point? Because it will reach its solubility product quickly and it will come out in the form of precipitate quickly. So already some ions are there. It's like this, children. We have a bus with 10 seats. 5 seats are already filled. 5 are to be filled. Next bus, we have 10 seats. 8 are already filled. How many more to be filled? 2, which will take more time. Naturally, the one in which the number of seats left are more. So here already some CO3 is there. addition of Ag2CO3 will not further increase much concentration of CO3. As a result of that, solubility of Ag2CO3 in Na2CO3 because of one common ion will be less. Correct? Now when you take AgNO3, naturally one of the common ion is which one? Silver. Am I clear or not? Third one, in pure water you can say solubility will be to some extent more compared to these two because there is no common ion furnished here at all, right? It will give you H plus and OH minus. So we'll say solubility in pure water will be bit higher. And 0.05 molar ammonia, this needs to be seen. Now we know, children, silver can combine with ammonia and result in the formation of ammonical silver, that is AgNH3 twice. So when you are dissolving Ag2CO3, some of this Ag will combine with NH3 and make a product in the form of AgNH3 twice. So what happens to the concentration of Ag? Decreases because it has combined with NH3 and resulted in the formation of a complex. So silver concentration is decreasing or not? Once it is decreasing, in order to increase this concentration, more and more Ag2CO3 can be dissolved. So the correct option will be, children, that you can have more dissolving of what? Ag2CO3 in ammonia and water. But compared to water with ammonia, it will be more because silver is able to make complex with ammonia. It's able to make a product with the ammonia. So this concentration of silver will keep on decreasing regularly. So in order to increase the concentration of silver, more and more Ag from Ag2CO3 will dissolve. What does it mean? Solubility of Ag is increasing. That means on the whole, solubility of Ag2CO3 in the media will keep on increasing. So the correct option will be option 4. Yes, again this is common ion effect. Again it's a concept of presence of ion which is being furnished by the salt which is added to it. That is sparingly soluble salt. Is it clear? Excellent. Next question. So these can be your homeworks. You can do these two questions with ease. We have been given solubility product of AgBr. Question number 15. So for AgBr, solubility product is given. Children, how much? 4.9 into 10 to the power minus 9. Right. What will be solubility? So solubility you have to calculate. Options are 7 into 10 to the power minus 4 moles per liter. Option 2, 7 into 10 to the power minus 5 grams per liter. Option 3, 1.316 into 10 to the power minus 2 grams per liter. And option 4, children, 10 to the power minus 3 grams per liter. These are the 4 options given to you. So naturally, children, you will calculate solubility. For AgBr, what is Ksp equal to S square? Because Ag will be S, Br will be S. Alright. When it breaks, AgBr breaks will give you Ag plus plus Br minus. So 1 minus S, this will be S. So what will be Ksp equal to S square? What will be solubility equal to Ksp root value? So what is Ksp? S square. What is S equal to root of Ksp? What's the Ksp value given to you? 4.9 10 to the power minus 9. Yes? Yes or no? So that will be 4.9 into 10 to the power minus 9 root of that. So that will be equal to 7 into 10 to the power minus 5. Then what we are asked to find out? 7 into 10 to the power minus 5. Right. So 7 into 10 to the power minus 5. Very simple, children. 49 can be made 49. 10 to the power minus 9 will become 10 to the power minus 10. Root of that will become 10 to the power minus 5. 49 will become 7. 7 into 10 to the power minus 5. What? Moles per liter. Any option like that here? 7 into 10 to the power minus 4. It's grams per liter, not correct because it's moles per liter here. 1.316 not given. So it is moles per liter. Convert this into grams per liter. How can you do that? Into molar mass. What's a molar mass of AgBr? Silver bromide molar mass. It's almost 188. Multiply it. You will get your correct option. And mostly option 3 will be the correct option. Yes, 188 multiplication. This will increase further. So it will be 10 to the power minus 2 grams per liter. Correct option will be option 3. Right or not? If your answer was in moles per liter, some option would be matching with 7 10 to the power minus 5, then you can pick it up. But none of the option is matching 7 10 to the power minus 5 moles per liter. It's grams per liter. So convert that into grams per liter. That will be into molar mass. So it will be grams per liter respectively. Solve it and get it done. Clear, children? Right. So rest of the questions are quite easy from here. I didn't find it difficult to solve. So these are some of the questions with respect to ionic equilibrium. Now chemical equilibrium and ionic equilibrium MCQs are done. So next I'll be starting my next chapter with respect to discussion. Right children, have a good day, read hard and keep revising things well. Thank you.